there. And there it is. It's probably got some cancer-causing cosmoline on it so it doesn't rust when they ship it over from China. But that's how they pack it. I mean, you can see the jaws packed on the side. Okay, so let's set that down. Let's pull the jaws out one at a time. Yeah, nice individually packed jaws. Okay, so we'll just set this down over here. Then we'll go ahead and open it up. Oh, it's already got a set of jaws on it. How about that? And there it is, the Grizzly 4-jaw chuck. Scroll chuck, that is, self-centering. Now, let me go ahead and let's take the back plate out. You got some little screws with a back plate there. You got the studs that hold it in, the camlock studs right here. Okay, and then you got the actual back plate. Again, it's wrapped up in this cancer-causing paper. Probably shouldn't be touching the shit. And there it is. It's just your basic run-of-the-mill back plate. It's going to go on this lathe right here. See, I have a 6-inch 3-jaw, and right now on the machine I have the 8-inch 3-jaw on the machine for doing some bigger work. And then down here I've got my 4-jaw independent chuck. But see, that's a pain in the ass. You know, when you're trying to cut square stock, you know, I got some right here. You know, when you're trying to machine this, you know, when you want to machine this right here, you don't want to spend a lot of time, you know, putting it in the 4-jaw chuck and then having to center each chuck up. Or, you know, I don't want to spend a lot of time making a collar to go on it. You know, making a collar to go on it like that so I can grab it inside the 3-jaw. You know, that's a way of doing it right there, but that's time consuming right there. So it's easier just to buy the 4-jaw chuck and clamp it down and you're done. So let me go ahead and pause again and let's pull it out and we'll examine it a little bit closer. Okay, here it is taken out. Got the oilcloth. As you can see, it has a cover in the back. The cover is just to hide, you know, keep everything chips out of the scroll. Yeah, this is what they call a plain back chuck right here, where you have to machine your back. This chuck basically it can be universally used on any machine. You just got to get the back plate that fits on it. This is a non-back plate chuck. I don't know if you can see that there, but as you can see, you know, the studs, it's all one piece right here. You know, and the studs are machined into it right here. So we're going to go ahead and install this. Let me get it lined up and we'll see how it is, because you're going to have to, this is going to have to be machined down on the lathe to fit the chuck, so that way it stays true. Okay, now this is the back plate. Now as you can see here on the back, this diameter right here has got to be machined down to fit inside this bore here. Now we can measure it. Let me break out the calipers. Oh, here they are. And we'll measure it. So this back plate here is 5 1/62 in diameter, but the bore on the chuck itself is 1 5 inches and 1/11. So they give, and the reason they do this is so you can make sure the chuck runs true to your spindle and your machine. Now, what I gotta do is I gotta put all the pins in it and everything. Put the pins on the back. Take the 8-inch off the spindle, clamp the plate on it, and then I'll indicate to make sure the plate's true. If it's not, then you machine it true to the machine right there. That's why they give you a little extra. That's why they give you a little extra meat right here on it. So let me get that started. Let me get the 8-inch off the machine and get the back plate put together. I'll be right back. Okay, now that I got the 8-inch off, it's sitting on the floor right here. I just want to make sure that my spindle is going to be clean, especially here where the taper is, because this is pretty much what holds the chuck center line on it. So you just make sure that everything's clean, that there's no chips inside. That's the cam holes right here. You get all that cleaned up. Sometimes, the chips will work their way in there and they'll get pinched in there and they can throw you off a few tenths. And you don't want that. Now, if you notice, there's a 0 stamped in right here. I don't know if you can see that there, but there's a 0 stamped in right there. Grizzly did that there when they centered the original chuck with the machine. And that'll be my reference point to where the new one will go to. Okay, so let me get the studs in. Okay, now I'm putting the studs in, the camlock studs in. Get them started, because you're going to have to adjust the height of them by the way they lock into the main spindle. And what I do is I put a little lube on each one. It's always good, to keep everything well lubricated, because being that this is cast steel, what you do is you screw them in there. Now you may notice, if you notice on them, like I said, once again, I don't know if the camera can see this because they're black, but there is a little line right here. There's a little line machined into all the studs. Now that's normally where you screw them down to. So you screw them all down to about that same point. It just gives you a reference point where to start. You make sure the little cutouts right here, the little cutouts in there are facing so you can put the screws in there. Now you do this all the way around right there, so let me get that done. Okay, there I have the studs in. I don't have the lock screws in because you're going to have to adjust them. I got them all the same height sticking out on the little line right there. I've got the inside lubricated, the taper. What I'm going to do is I'm just going to put it on the machine, and then we'll have to lock each one down to see to where it locks, because see, you have lines. You have indicators right here where they want you to put the lines. So this is 0. So we'll turn this around, and you can see that one goes way past the limit mark. So that stud's going to, see, I can turn it completely around. So that stud's going to have to be screwed in a little bit so that way it pulls on it. And you just got to go through the process of checking each one. See, that one bites right there. Okay, see, it's right there. The line is right where it should be at the 6 o'clock. Okay, the next one, the line is here on 12, so let's see where it bites in at. Okay, that one bites in right up a little bit past 6. That's good. Let's do the next one. And you repeat this process until you get them all to the same place. That one that was the first one that was loose, it means the plate's going to have to come off, and I'm going to have to screw that one down a little bit. See, this one, can't even move it. See, it's too far in. So that one's going to have to be in. And you just take a marker and just mark it. That's what I'm going to do. I'm just going to take a felt tip, which I have laying around here somewhere. And I'm just going to mark it right here. Just put a 0 on it so I know which is which ones I need to adjust in or out. And then you go and repeat the process to the next cam lock. See, that one goes and it locks. I don't know if you can see the line, but it's about right there. You want them generally right here. They give you an arrow to where it should be at. You shouldn't go no more than 3/4 of the way around. See, there's the 0. See how that one goes all the way around? Now let me go ahead and get all this adjusted. And this is important. You got to make sure that all the cam studs are being pulled in under tension, so that way this plate is sucked in up against the taper. It doesn't rely on anything else. It seats up against the back, but the taper and the bore is what holds it on center line to the spindle. And then we'll check all this with an indicator to see how true we are. If we're not, we'll machine it down. So let me be right back. Remember, always put a little bit of oil in these fresh threads right here because they are dry. And the last thing you want to do is tear the threads out. Now I got my cam studs adjusted. Now it's just a matter of placing in all the little locking screws in the holes and locking them down. So let me get that taken care of. Okay, getting the screws in there. Now you remember, you don't have to gorilla tighten them down with mega tonnage of torque on it. All you got to do is just put them in there snug, maybe a pound or 2 of torque, because they're not going to come out. All they are is to keep the pins from spinning around. But that's all you got to do. I have never had a cam lock chuck, fly off the machine or come loose. I've never even broken pins yet. And I abuse the shit out of these things at work. So we get all that down, and then we'll get it mounted to the plate. Okay, here we are, mounted to the spindle. Now don't worry if you see some of your little lines, you know, not lined up with the arrow past 6 o'clock. As long as you don't go anywhere towards 75% of the way around, you don't want them at the 9 o'clock position. So like this one right here is right about the 7 o'clock position. That's fine because you can still torque it down and everything. But now they're all torqued. You can see we got the plate on there. Now let me get the indicator, and what I'm going to do is we'll put the indicator. This part doesn't matter. What we're going to check is we want to make sure that we got flatness, radial flatness across right in this area here. This is where the chuck sits. And then we'll machine this diameter down right here on the lip. But first we need to make sure that we're perfectly flat parallel to the spindle and everything. So let me go get the indicator and we'll set that up. Okay, we have the indicator set up on it. Just make sure you set up where the tip doesn't fall inside the hole. Make sure you use the ball tip on it so that you're not gouging in. And then of course, you know, we got to zero out the indicator right there, and then we're just going to spin it around. Let me see if I can get where you can see that. It's hard to see, I got reflections everywhere, but we'll spin it around. And I have less than 5/10. Let's see, because right here, I don't know if the camera will even focus that close. Let me see, focus. Yeah, see, it wants to focus on everything else around me. So if you spin it fast, the needle will bounce. So what you gotta do is you just spin it slow. Less than 5/10 on it, which is acceptable. My clothing lathe at work has got more than 5/10, and it cuts perfectly true when you got it all set up and everything. So, and that's an American-made lathe. So we're good here. Now we just got to measure this diameter here, machine it down, and then fit the chuck to it. Take a pass, fit the chuck to it. What we want is I want a nice tight fit on it. You know, I want to be able to snap it on there, and then, you know, use this to hold pressure on it, and then pull it back from behind with the screws. So let me go ahead and do that next and get that set up. Since we are flat here, I'm not worried about out around this here, the loping on it, because I'm not going to use that part. I just need this part to be concentric with the spindle, and this to be flat and parallel to the spindle. So let's go ahead and get the next process going. Okay, got the tool in there, and as you can see right here, come on, once again, will the camera focus on it? Probably not. Right here I have it set up. You hear it? Where it's just barely touching. It's barely scruffing. It's perfectly round because you can, well, it's not, it may be a thousandths odd because you can see a little drag mark right there. But this is 5 1/160, this diameter here. So now I have my DRO to 5 1/160. So that way I can take a measurement cut. I have my RPMs at 115. At 115 at this diameter right there, that's going to be about 200. That's going to be pretty close to 200 SFM. So what I'll do is I'll back the slide off a little bit. Now I have the machine on. Make sure everything's clear. We're on. I just can't get in there. And what I'm going to do is I'm just going to take a light kiss cut. Just until I barely see it touch the bottom, so leave a little undercut. See right there, it's got a little undercut. And I'll keep doing 5/10 at a time until I get to where the chuck just snaps on there. So let me get that taken care of. And this is going to be pretty time consuming. Probably take about 20 minutes to do this. So let me put the camera down. Okay, let's measure. The DRO says we're at 5 1/24 4/10. So let's measure with the actual calipers. Let's see what I get. Okay. 5 and 125. Okay, now this is where we're going to start test fitting this, because I know I use the calipers to measure it, but you got to remember the calipers here on the front have a square on it. They're flat, so you have to trig that out to get the actual measurement. The calipers are telling me that this is 5 and 120. So let's check. So what we're going to do is I'll put it on there. Let me get a hold of it. And I'll just, this one ain't so heavy. And I'll do a test fit. Okay, as you can see, it doesn't go on yet. See, I still, when you get it positioned just machined just right, it will just snap right on. So let me do a little bit more cutting. Get that cut down a little bit more. Because this is going to be a little time consuming now, because I'm going to take it down a few tenths at a time until I get that snap. Because I want no play in it. I want no play shifting sideways on it. So let me get that taken care of. Okay, now the DRO says I'm at 5/118.8, which is about 5/119. Just snap the chuck on there. Let's see. Oh yeah, look at that. No side play in it. Look at that, man. It almost basically holds itself up with no side play whatsoever. That's what I'm checking for here, is no side play. You'll feel it. So let me go ahead and take it back out of the machine so I can mount it to it. Okay, here I have it out. And as you can see, how machined, how tight I got that tolerance, that you got to line it up perfectly square to get it in, and then snap it in. That means it's what they call interference fit. Now some guys may say you want to leave 1 or 2 thousandths for expansion. Nah, I never have. I want the truck to be solid, because that's what gives it its rigidity. The more precise you machine all this, the more rigid it's going to be. Because you got to remember, you only got 3 little cheesy ass screws holding the back. Yeah, I could put it on the mill and machine more screws, but why? This will do fine. So let me get it locked down, and then we'll be able to see how true the jaws are. That I don't know, but I know that this will be all true now, because it was the interference fit between the back plate and the chuck itself. So that's going to be concentric as long as the chuck is ground, this part's ground true and everything. There is acceptable tolerance. A lot of industry standard is plus some, it's 3 thousandths out around this on the jaws, because it is a chuck lathe. If you want precision, you put a collet inside the machine. But then again, this little 6-inch chuck that came with the machine had only 5/10 TR on it with a bar clamped in it, and that was sticking about maybe 2 inches out. So that's the chuck that Grizzly put on, and that one has a little 0, which is indicated to the 0 on the spindle. But once I get this all set in, I'll stamp a 0 on it, so that way the chuck always goes in the same place every time. So let me go ahead and get this bad boy bolted together and put it back on the machine. Okay, here's the finished product right here. So not bad for $150 for the chuck and $60 for the back plate and everything. Once you get it all in, it'll go pretty true. Like I said, once again, I don't know if the camera can see the numbers on the dial. Let's see, as I spin it, it's got about 1 3/4 TIR on it. That's just a piece of aluminum bar that I put in there. That's a lot better than the 8-inch has. The 8-inch has got about 2.5 TIR on it. But see, that chuck already came together. It wasn't pieces like this. But that's your procedure of installing a chuck on the machine if you want to do the back plate. The thing good about a back plate is, you can put the chuck on anything. A lot of people say that, having the camlock direct, because you get your work closer to the spindle instead of having this thick plate here. Because you can see the thickness of it. Let me see if I have the tool here. See, it's about the thickness of that tool before it touches on the back of the spindle compared to this one. So you have almost 9/16 of an inch more sticking out. But what I need it for is I gotta chuck up some square parts. So let me get a part in there and we'll see. See, that's a lot easier to chuck up a square part. You just put the part in, clamp it down. You don't have to sit there and adjust each individual jaw. because when you do that, and then you got to indicate because your work could be moving around this way or up and down on a forward jaw independent chuck. That's why I bought this scroll chuck, this forward jaw scroll chuck right here, because when I got to turn these down right here, I got to put a little radius on them, I got to drill and tap them and stuff like that, and they're only going to be about 2 inches long. It was taking forever to do that. This is much faster because you can just break it loose, pop another one in, and boom, you're on the road again right there. Another addition to my Grizzly G